In the vast expanse of the Milky Way, an enigma unlike any other had taken up residence within the hearts and minds of astronomers worldwide. This celestial visitor, christened Three-Eye Atlas, had journeyed through the cold, desolate void of interstellar space, capturing the attention of scientists and stargazers alike. Originated from the uncharted territories of our own galaxy, it was a beacon of mystery, a puzzle waiting to be unravelled. For over a year, Three-Eye Atlas remained a subject of fascination as it approached the solar system. However, as it drew near to its closest approach to the Sun, an unprecedented anomaly was observed. Telescopes around the world documented a shift in its light, a change in its structure, and behaviour that defied all known natural laws. The James Webb, Hubble, and ground-based observatories all confirmed this strange occurrence. The object exhibited a countertail, a thin jet of materials shooting directly towards the Sun, contrary to the outward-pointing tails of all known comets. This anomaly was so unusual that it left even the most skeptical scientists speechless. As more data was collected, it became clear that Three-Eye Atlas was no ordinary comet. Its mass and gravity readings didn't match. It rotated unusually slowly, and it seemed to be moving lighter than it looked. Theories began to crumble one by one as researchers struggled to explain this enigma. Some speculated that the material might be resistant to radiation pressure, possibly composed of unknown elements or alloys that react differently to solar photons. Others suggested a more radical idea, that the tail wasn't natural at all, but an emission or exhaust from a controlled mechanism within the object itself. As the world watched, Harvard astrophysicist Avi Loeb and his team introduced the OEP scale, or Object of Extraterrestrial Probability, a ranking system inspired by the T-scale used to assess asteroid threats. This scale classifies interstellar visitors from level to level 10, based on the number and severity of unexplained anomalies. Loeb placed Three-Eye Atlas at level 4, describing it as an object with multiple persistent anomalies and no satisfactory natural explanation after extensive analysis. This classification put Three-Eye Atlas in the zone of potential technosignatures, implying a 40% chance that its origin might not be natural. This revelation sent shockwaves through both the scientific community and the public. As Three-Eye Atlas moved away from the Sun, it entered solar conjunction, becoming invisible to telescopes for several weeks. During this period, debate raged on about its origin and nature. Some believed it might be artificial, while others argued that it was an entirely new category of interstellar object, built by physics we haven't yet discovered. Just as the world was beginning to lose hope of ever understanding Three-Eye Atlas, it reappeared. As it emerged from behind the Sun, telescopes across the globe turned their gaze towards the coordinates predicted months before. But what they saw wasn't what anyone expected. Instead of fading, as most comets do after perihelion, Three-Eye Atlas was brighter, much brighter. Its albedo, the measure of light it reflects, had increased by nearly 400%. Its apparent magnitude rose beyond all models, meaning it was somehow reflecting far more sunlight than its surface area could possibly allow. Infrared readings revealed that its temperature hadn't increased. It had stabilized even as it moved away from the Sun. Something inside it was regulating its heat, emitting and absorbing energy in perfectly balanced cycles. Then came the strangest part. The anti-correlated jet that had once pointed towards the Sun was gone. In its place was a thin, pulsating beam of faint ultraviolet radiation extending sideways into deep space, steady and rhythmic like a cosmic heartbeat. To observers it looked deliberate, controlled. The world's observatories began recording every pulse. The pattern wasn't random. It repeated every 247 seconds exactly, as though the object had begun broadcasting something. Within days, data scientists from the European Southern Observatory and MIT began decoding the ultraviolet pulses. At first, they seemed meaningless, a repetitive burst of radiation fluctuating between two intensities. But after filtering through frequency compression algorithms, one of the analysts noticed a striking pattern. The pulses corresponded to prime numbers. The universal signature often suggested in CT research as the simplest way an intelligent civilization might establish communication. First 2, then 3, then 5, then 7, then 11. The sequence continued for hours before resetting. The chances of a naturally occurring prime sequence emerging from radiation fluctuation are astronomically low, practically zero. And yet 3i Atlas was emitting it with precision. This revelation divided the global scientific community. Some argued that this was merely a coincidental modulation due to rotational dynamics. Avi Loeb and his Harvard team disagreed. They publicly stated that this was no longer an astronomical event. It was a message. Soon, smaller observatories from Japan to Chile confirmed the data independently. Whatever 3i Atlas was, it wasn't acting like debris or even a passive body. It was behaving like a system, a machine executing a coded protocol in response to solar interaction. And it had just begun transmitting again. To investigate further, the James Webb Space Telescope was reoriented toward 3i Atlas, its instruments calibrated for hyperspectral imaging. What it captured sent shockwaves through every scientific institution. Beneath the object's reflective surface, Webb detected a geometric structure, a lattice-like framework running beneath its crust, composed of repeating hexagonal plates aligned with its rotation axis. It was not random, not fractured, not natural. Each plate measured precisely the same dimension, reflecting light in mathematically perfect intervals. Webb's analysis suggested the structure was composed of a highly conductive nickel-titanium alloy with atomic purity higher than anything found in nature. In simple terms, 3i Atlas wasn't just unusual. It was engineered. The discovery was quietly confirmed by spectroscopic data from the JWST's NIRSpec instrument, which revealed controlled polarization shifts as if the object's outer layer were adjusting itself in real time to minimize glare. This wasn't a rock. It was something built to hide, adapt, and survive interstellar travel. But if it truly was a craft, the question that haunted scientists worldwide was simple. Where was the pilot? On the night of its reappearance, something unprecedented occurred. Without warning, the rhythmic ultraviolet pulses ceased. For 12 full hours, 3i Atlas went dark, completely inert. Then, precisely 2:17 UTC, the object made a sudden, measurable adjustment in its velocity vector. It wasn't deflection from radiation or gravitational pull. It was course correction. Its trajectory shifted by 0.09 degrees. A tiny angle, yet one that no natural body could achieve without external propulsion. The maneuver placed it directly on a new path, away from Jupiter's orbit and toward the outer solar system, accelerating at 14 meters per second squared, far beyond the capability of any known cometary outgassing. Observatory has scrambled to recalculate projections. The new route would take it toward the heliopause, the boundary between our solar system and interstellar space, but not randomly. Its exit trajectory aligned almost perfectly with the coordinates of its original inbound path, as if it were returning home. Before disappearing once more into the deep, 3i Atlas submitted one final ultraviolet pulse. It wasn't a sequence this time, It was a single sustained beam that lasted exactly 13 minutes and 37 seconds, long enough to be recorded, analysed and archived. Its spectrum carried something that changed everything. A faint, encoded signature resembling structured binary information. For the first time in history, an interstellar object may have not only visited our solar system, it may have spoken back. As one astronomer wrote in the final line of his report, "Perhaps we were never meant to find it. Perhaps it found us." As the world continues to study the data collected from 3i Atlas, one question remains. What does this mean for the future of astronomy and the search for extraterrestrial life? Only time will tell. But one thing is certain. The universe remains a mystery, and there is much more to discover. Meanwhile, the scientific community grapples with the implications of 3i Atlas. Some question whether the object is truly artificial, while others argue that it may be a natural phenomenon we don't yet understand. The debate rages on, but one thing is clear. The discovery of 3i Atlas has forever changed our understanding of the universe and our place within it. The scientific community has established a team of experts to study the data collected from 3i Atlas. This team, known as the 3i Atlas Study Group, TEASG, includes representatives from various institutions and disciplines, including astrophysics, engineering, and computer science. TEASG's primary goal is to decipher the encoded binary data emitted by 3i Atlas. They are using a variety of techniques, including frequency analysis, statistical analysis, and machine learning algorithms, to uncover patterns and meaning in the data. One of the most intriguing aspects of the data is its repetitive nature. The ultraviolet pulses emitted by 3i Atlas are consistent in their duration, frequency, and pattern, leading some to speculate that the object may be using a form of communication that we have yet to understand. Another important aspect of the data is its encoding. The binary data, is to be structured in a way that suggests it is meant to be read and interpreted. The data is not random, but rather appears to be organized in a systematic manner. Some members of TEASG believe that the data may contain instructions or information about the object's origin, purpose, or technology. Others are more cautious, arguing that the data may be nothing more than a byproduct of the object's internal mechanisms. Regardless of the ultimate interpretation of the data, the discovery of 3i Atlas has opened up a new frontier in the search for extraterrestrial intelligence, SETI. If the data does indeed contain meaningful information, it could be a groundbreaking event in the history of humanity. In addition to its potential significance for SETI, 3i Atlas has also generated interest in the field of astrobiology. Some researchers believe that the object could provide insights into the possibilities of life beyond Earth. For example, the object's unusual properties and structure suggest that it may have been engineered to withstand the harsh conditions of interstellar travel. This raises the possibility that other advanced civilizations may have developed similar technologies to explore the cosmos. Furthermore, the object's apparent ability to communicate using ultraviolet radiation raises the possibility that other forms of life may also use this wavelength to communicate. This could be important for future SETI efforts, as it suggests that we should be focusing our search in this part of the electromagnetic spectrum. Of course, there are also those who are skeptical of the object's origins and interpretation. Some argue that the data may be nothing more than a coincidence or a natural phenomenon that we don't yet understand. Others question the object's true nature, suggesting that it may be a hoax or a natural phenomenon that has been misinterpreted. Despite these concerns, the discovery of 3i Atlas has generated excitement and interest in the scientific community. It has sparked a renewed interest in the search for extraterrestrial intelligence and has raised important questions about the nature of the universe and our place within it. The study of Three-Eye Atlas is ongoing, and its mysteries continue to captivate scientists around the world. As we continue to study the data and learn more about this enigmatic object, we may uncover new insights into the cosmos and our place within it. We may even find answers to questions that have puzzled humanity for centuries. Only time will tell, but one thing is certain. The universe remains a mystery, and there is much more to discover.